Hello, welcome back to Data Science Monster. Today we are diving into some important hyperparameters of decision trees in machine learning, but not in a boring way, right? I hope all of you are ready to hear the story. Imagine you are planning a road trip with your friends. Your decision tree is the map and the hyperparameters max depth, min sample split, min sample leaf, maximum features, criterion. These will determine how smooth your journey will be. So buckle up because we are going to explore this with a fun story, right? So the first, as I said, we are planning a road trip. You have a map with multiple routes and lots of places you can stop. But here is the thing. You don't want the trip to take forever, right? That is where max depth comes in. It's like deciding how far you want to travel before stopping. In machine learning terms, max depth limits how deep your decision tree can go. If it is too deep, the tree might overfit, getting stuck on details that don't matter. If it is too shallow, you might miss some cool, meaningful stops. For example, if you set max depth is equal to 3, the tree can only go 3 levels deep, meaning it won't consider too many small decisions. A higher max depth, say max underscore depth equal to 10 means your tree will consider many more layers of decisions but may end up with overfitting. So what is min sample split? Now imagine your group of friends on the trip is deciding when to split up to explore different places. So should you split if just one person wants to go elsewhere, or should there be at least a few people? That is exactly min sample split does. It decides the minimum number of samples needed to split a node. Example, if minimum sample split is equal to 2, even if only 2 people want to explore a side route, you will split. If minimum sample split is equal to 10, you will wait until at least 10 people agree before splitting the group. So this prevents your decision tree from splitting too soon on small insignificant decisions. So the third one is min sample leaf. How small should the groups get? So now think about the leaf nodes at the end of your journey. It's like deciding how small your final group should be. Should you end with just one person in a group, or should you ensure there are at least 2 or 3 people in each group? That is where min sample leaf comes in. If min sample leaf equal to 1, each leaf can have just one person, meaning you could end up with very specific decisions. If minimum sample leaf is equal to 5, you won't stop until there are at least 5 people in a group, ensuring your decisions are a bit more generalized, right? So the next one, maximum features. How many travel destinations should we consider? Let's say you are choosing destinations based upon the different features like weather, cost, scenery, etc. But sometimes you might only want to consider a few of those features, right? That's where maximum features comes in. It decides how many features the decision tree should consider at each split. In case if we give max features equal to 3, you will only look at the weather, the number of tourists and the distance, the 3 features in this particular example. In case if we give like max features equal to SQRT, that could be a random selection of features at each decision point, keeping those things diverse, and then it may prevent overfitting. The last important hyperparameter is criterion. What is our decision making strategy? Finally, when making decisions on your road trip, how do you decide where to go? Do you pick based on minimizing cost, or maximizing fun. That is what the criterion parameter does. It helps the decision tree figure out how to make the best splits. In case if you give criterion is equal to Gini, like splitting your group based on which choice would have the least confusion or disagreement. Criterion equal to entropy. Imagine using information to minimize the randomness in your group's choices. This approach looks at how uncertain or mixed up your options are. Already I have posted a video about entropy, how to calculate it mathematically. I will also try to give the link over there. In case if I have missed it, please let me know, right? So these hyperparameters like max depth, minimum sample split, minimum sample leaf, maximum features, and criterion help shape the journey of your decision tree. They determine how far you go, when to split up, and how small your groups get, what features to consider, and how to make the best decisions along the way. Hopefully, with this fun road trip analogy, these terms make a lot more sense. Don't forget to like and subscribe if you found this useful, and comment below with any other AI or machine learning concepts you would like to see explained. Thank you.